So a quick summary of Taylor series polynomials, because eventually we'll be using this to solve for differential equations, which is not so fun to do, we'll just say. So again, just a brief review of Taylor series polynomials. We'll eventually do power series more precisely, but Taylor series is always an introduction to it itself. So given an nth derivative degree at x naught, centered at x naught, this is going to be our approximation, our Taylor series approximation. Which means if you have degree 2, we have second degree and so forth. Degree 5, this is 5, fifth degree, eventually going down the list. Okay, so summed up into a summation notation looks like this. So all this is a brief, rundown of what it represents. So all we want to do is determine the fourth degree Taylor polynomial for each individual one at x equaling 2. So it's centered at 2. Okay? So for all these cases, it's going to be x minus 2. Okay? All right, so e to the x. So we want a fourth degree. So we have to take the derivative 4 times. So if I just go down the list, so we're going to take f at 2, which is just e to the 2. Take the derivative at 2, so the derivative is just e to the x. So it'll be same thing. And the nice thing about e to the x, it's going to be the same no matter how many derivatives you take. Right, it's going to be the same no matter what. Which is nice because these are all constants. So really what's changing from 1, 2, 3, 4 is basically the bottom number. Okay. So in our case, our approximation of e to the x will be f of 2, so e of 2, plus the derivative, which is e to the 2 at that point, times x minus 2 to the first power, in this case, plus f double prime, so we're here now, so e squared times x minus 2 squared this time. So notice the derivative and the power are the same, divided by n factorial, so 2 factorial, plus the third derivative to the power of 3 over 3 factorial, and then finally plus e second to the fourth power over 4 factorial. There we go. So again, just a brief introduction, or review of Taylor series expansions. Okay. So now we go into more elaborate cosine. Okay, so this time it's going to alternate in each case. So we'll just start with the basic, and we want fourth degree, so we take it 4 times. So the derivative of cosine will be negative sine. The derivative of sine is positive cosine. 2 more times, so 3. This will now be positive sine. And then finally the fourth derivative back to negative cosine. Or sorry, the derivative of sine is positive, so positive cosine. Yeah, there you go. Back to it again. One complete circle. Okay. Again, x naught is 2, so again it's going to be here. And without using a calculator, I'm just going to plug in what cosine 2 is, sine of 2 is, whatever it is. So essentially, cosine x is approximated by cosine of 2 minus sine of 2 times x minus 2 minus cosine of 2 times x minus 2 to the second power over 2 factorial, and this is plus sine 2 to the third power over 3 factorial, and then finally back to cosine. There we go. Okay. Now the best part is sine is it's the same thing as cosine, right? They're just going to be opposites. So basically it starts here with a plus, with a positive, and just goes in that portion. So I'll just go straight from the derivatives to this portion. So this is going to be approximately itself. So sine of 2, derivative of cosine is positive. Derivative of sine is positive cosine. Derivative of cosine is negative sine. Derivative of sine is positive cosine. And the last one, the derivative of cosine is negative sine, so it becomes positive. And there we go. Okay. So how are we actually going to be using this kind of stuff? We're not going to go to like the 5th degree, 4th degree. We're just going to go to some type of degrees. Okay, and then you're going to do a little understanding how it's going to go forward, especially when we do power series. So first, again, just going back to Taylor series, we want to just get our first breakdown. How do we do this using Taylor series expansions? Okay, so we're going to do a little hard. We're going to go to the degree 5, just for a little bit of practice. So we want to find the Taylor series polynomial of degree 5 for this solution around x equaling x naught of the initial value problem. Now in this case, x naught is going to be 0, right? It's always what's being evaluated. Okay, there and there, right, as you can tell. Okay, so according to our definition, so this Taylor series expansion of degree 5 will be is just itself at evaluated x naught, which is 0, plus the derivative at that value times x minus 0 in this case, the first power, plus second derivative at the 0 power times x minus 0 to the second power over 2, factorial. And we just keep going in that same pattern. So 1, 2, 3. And 2 more. And then the last one. Now, the best part is we already know the first two. It comes from here. And we already know y double prime. It's right here. So we have to figure out 3, 4, and 5. Okay. So let's just write some stuff down. So y of 0 is just given by is 10. Y prime of 0 is given to be 5. Okay. Y double prime is already given to be from the question. So now all I do is plug in 0, 5, and 10, respectively, where we're supposed to go. And this will give me 15. Okay, so right off the bat, we can always break it down. So first one is going to be 10, plus next one is going to be 5. So if I follow this pattern, it would be 5x plus 15x squared over 2. Okay. So from these three, we already have 1, 2, 3. Now we got to just take the derivative 2 more times. 3, 4, and 5, or 3 more times actually. So y triple prime. So this we got to be careful of because we actually have to do product rule and mostly just product rule. So this derivative is just going to be 3y double prime. However, here we have to use product rule because it's implicit. So because it's a product rule, we're going to have 2x y plus x squared y prime. And if you plug in all three now, or actually 4, so plug in 15, 5, 10, and 0 into here, we will get 45. So the next one is going to be plus 45x to the third over 3 factorial. All right, so now we do the fourth derivative. And notice now we have to do double product rule. And then this ends up being, actually, basically the same process we did here. Right, this ends up being looking like that with just a double prime, so. Like that. Okay. And again, now plugging in all 1, 2, 3, 4, 5 things into there, we end up getting 155. So the next one is 155x to the fourth over 4 factorial. And now again, I'll start it off. This is to the fourth now. This is to y prime. And then from here on, you could technically add these together, give you 4. So here and here, again, a double product rule when it comes to it. But eventually, you'll get 495. So last one, plus 495 x to the fifth over 5 factorial. And that's our Taylor series expansion of degree 5. Okay. So let's try one more. Not so crazy. We'll just go up to 3 now. So find the Taylor series expansion of degree 3 for the solution with the initial value problem. So I'll use the same template because it follows the same template. X naught is still 0. So it literally just follows the same pattern as above, which is nice. Okay, so we know the first one. So y of 0 is 0. Y prime at 0. We just plug in 0, 0 everywhere we see x and y. And we just get 1 over 1, which is just 1. Okay, so I'm going to rewrite this to make it a little easier for myself using exponents, because those are the same. So now when I take the derivative, it's a chain rule. Derive the outside times the derivative of the inside. Gives us that. And now if I plug in all three things, 0, 0, and 1, into this second derivative, we end up with negative 2. Okay. So as we go about, if I follow this process, so first is normal derivative, so it'll be 0 plus y prime, so 1 times x minus 2x squared over 2 factorial. And now we're just going to do one more because it's degree 3. So the triple derivative is basically a combination of product rule and chain rule. Right, so 2 different functions. Here is one, here's the other one. So we end up getting this. And again, now if you plug in all four things, 1, 2, 3, 4 into all of this, and we eventually get just a simple 10. So the last one will be plus 10x to the third over 3 factorial. And there's our Taylor series expansion of degree 3.